Good afternoon, everyone. It's been just over 100 days since I've been at Siemens, and I'm saying that because as I interact with people in the company every single day, I feel like a kid in a candy shop because the opportunity for innovation is just huge, really, really huge, to push the boundaries of what industry can do. So it's great to be here with all of you at the end of what's been an incredible series of deep dives. I've learned a lot and hope you have too. Over the last few hours, you've heard how Siemens is connecting data across every part of our portfolio, how the data fabric now runs through our factories, our grids, our trains, and our buildings. You've also seen glimpses of how AI is already emerging inside those businesses. So what I'm going to try and do now is to try to bring all of it together to show what happens when that data fabric meets intelligence at scale. That's what we call industrial AI, the point where all of those threads converge, where Siemens' digital and physical strengths come together to change how the real world works. This is the next stage of growth for Siemens, making industrial AI real, safely, responsibly, and at scale. So let's start first with how our customers are already experiencing it.
The whole automotive industry changes with AI. We need AI in the shop floor for better performance, for higher quality products. The Siemens Industrial AI Suite and the Industrial Edge helps us to deploy the future use cases in our factories. For us, it's very important that it's a standard solution because we can roll it out on every shop floor and it's scalable.
Running a data center is complex and can waste a lot of energy if not done right. We use Siemens AI to improve our HVAC systems. We make them smarter and more flexible. The results are impressive. We cut our energy costs into more than half.
We have to do maintenance, fault checking, debugging of the system post-delivery. So if this could be done more efficiently inside or off-site, that's a key benefit, in my opinion, for Industrial Copilot.
The place where AI can have the biggest impact in our factory is in the engineering of processes, in the maintenance of machines, and in making the life easier for our people here.
So when you ask our customers what industrial AI means for them, I think their stories say it best. These aren't pilots, what you're saying, they're real production results. And together, they show you something very important. The next breakthrough in AI is unfolding in the real world. So in the past, AI has mostly lived in the digital world, analyzing data, generating text, like the kind of experiences we're used to interacting with chatbots like ChatGPT. But now you're starting to see AI move into the physical world, into the machines and systems that make, move, and power everything around us. This is industrial AI, intelligence that acts, not just thinks. And that shift from the virtual to the real is what comes next. Just as electrification defined the 20th century, I think industrial AI will define the 21st. It will reshape how we design, how we build, and how we operate the physical world from bits to atoms, from simulation to steel. In the process, the entire industrial value chain will be redefined, where design, engineering, manufacturing, and operations become one continuous intelligent loop. And no company is better positioned to lead that change as Siemens is. Siemens is the global leader in industrial automation and software, connecting the entire value chain from design to operation, as you've seen many times today. Roughly 1 in 3 industrial machines worldwide run on a Siemens controller. So we combine decades of domain expertise with advanced simulation, automation, and digital twin technology, as you've seen before, and that breadth across design, build, and operations is what will allow Siemens to bridge the digital and physical worlds like no one else can. And it's that connection that generates something even more powerful, data. So let's look at the scale of that data foundation. Across our portfolio, Siemens Technology generates trillions of real-world data points every single day. Data that comes directly from machines, grids, and buildings. We now have millions of connected devices in the field, and we have a partner ecosystem spanning hundreds of companies on Siemens Xcelerator. The way I think about this is that each connection feeds a common data layer, a living map of the physical world. And that's what gives our AI models the context and accuracy that others can't match in the future. So, and when you combine that strong data foundation with AI, you are actually starting to see impact everywhere. So across industries, our customers are already seeing it. And you've heard a lot of the examples earlier today, but I'll point out to a few right now. At DMG Mori, production ramp-up times have fallen by about 40%. And if you look at Tata Steel in the Netherlands, the predictive maintenance has cut breakdowns by 2/3. And at the Bank of Montreal, AI cooling has reduced energy by more than half. Now, each of these results looks quite different, but the pattern is exactly the same. When you bring intelligence into the physical world, you create measurable value. And as many of you know, value is hard to come by when we talk about AI, but here, you've got no other option but to show measurable value in order to be successful. So the question now becomes, how do you scale that value from individual projects to an entire ecosystem? And that takes us into the future. We scale it through 4 strategic layers that compound intelligence over time. The first step is that we bring intelligence into the machines, directly into the machines, the factories, the grids, and the buildings. And at scale, every physical asset that can sense, decide, and adapt becomes a continuous source of efficiency and value. And over time, these capabilities will compound, creating entire ecosystems of connected learning assets. That's how Siemens scales industrial AI, not as projects, but as a living learning network where there's continuous data flow in and out and allowing our AI models to get smarter and smarter over time. So let me now give you a glimpse as to how that future could actually look like. This list that I'm about to show you is not exhaustive by any means, and it's also in no particular order. We're just scratching the surface with some of these ideas. So the first idea here is generative simulation. Today, as you may have heard, simulations calculate, but tomorrow they will foresee. And so what's happening here is that weeks of simulation is compressed into minutes, and that's time to market redefined for a lot of our customers. So let me actually take you through a simple example. Assume you're an engineer trying to design an electric car. One of the ways you get there is maybe you start with a traditional car design, and then you try and take things out of that so that you make the car lighter. And you want the car lighter because then the battery takes the car much longer distances like you would want for an electric car. And as you're doing that change, and as you're removing things and adding things to the design, every single time you have to run these simulations. You have to run these simulations for aerodynamics using computational fluid dynamics. You have to look at thermal cooling. You have to look at things like the flow of energy there. And so you've got to run a lot of these simulations every single time you make a change. And these simulations are computationally extensive. And you have to run things like computational fluid dynamic calculations and also things like finite element analysis techniques. Now, what you can do with physics-aware generative models is that you can simply learn from thousands of simulations that you've seen before, and then you can instantaneously predict what's going to happen in those spaces. For example, you can come up with the thermal profiles instantaneously, and you can also do things like figure out what the drag coefficients are instantaneously. So the next idea I've got here is on the industrial foundation model. And you've heard a lot about this in the past. Today, models are mostly assist. They assist you in doing your work, and hence the co-pilots, right? But tomorrow, I think these models will create. So if you're familiar with generative AI models today, what they do is they just generate text for you. If some of you have tried some of the more advanced models, the models generate images for you and also videos for you. But there's no single model out there, generative AI model out there, that can take your intent and convert it into an engineered design. And so that's what we're talking about here. This is going to be a very powerful tool when our customers have access to it. Moving on, idea number 3 is in the area of buildings. And today, buildings are controlled, and tomorrow they will self-optimize by themselves. So if you look at buildings today, and if you look at operators that operate the building today, the way they operate the building is pretty rule-based, and it's very reactive. And they have to deal with very many different systems that are out there that help with the operations of the building. And they have to deal with complex things like occupancy dynamics, and they have to deal with the weather outside. And so assuming that you've got a generative model that is able to combine all these signals together, you could make the lives of these building operators a lot more effective when buildings are able to sense and orchestrate energy, safety, and comfort on their own. The last of the ideas that I had today, it's on production lines, essentially. Today, factories are fixed, but tomorrow they will adapt. So if you look at a production line today, there's a bunch of cells in the production line. And some of those cells have robots that have been very programmed in great detail to do exactly a specific task. And what that means is you've got precision, but you don't necessarily have the agility. So in case your requirements change, it's going to take you a lot of time to reprogram the entire production line. And so with models today, you have world knowledge in the models that we have today, and that combined with things like vision language action models that run on robots, you can completely change that equation. Production lines can reconfigure themselves overnight, combining precision with agility. So hopefully what you're seeing, what I'm seeing, which is each of these ideas shows AI moving further from the digital worlds to the real worlds. And all of them point to one simple truth. Industrial AI is no longer theory, it's execution now. That brings me to the end of my presentation, and I want to leave you with a visual image of what we've discussed. If you walk through a factory today, imagine you're walking through a factory today, you see something really rare. You see design and steel living in the same room. Together, I think they symbolize what Siemens uniquely enables: the fusion of bits and atoms, code and craft, thinking and making. I feel like that's where AI belongs today, embedded in the rhythm of how we build the world around us. That's the future that we're working towards, and I think Siemens is leading the way to make industrial AI real and at scale. Thank you so much.